session of our weekly data science internship webinar. Good afternoon, everyone. My name is Jacob Agboro, and I have with me here my colleague, Femi.
Good afternoon, everyone from Nigeria. My name is Femi.
All right. Thank you, Femi. Getting started, we would like to take a few of your comments on your experiences so far and your expectations for the stage C that just started. So please indicate by show of hands if you are on this call, or post a comment if you are on our YouTube channel. Nobody yet. All right. Seems like 10 more seconds to see if we would get any comments. Okay, so without wasting much of our time, we would go to the program for today. And I would like to turn the mic over to our program manager, Toby Loba. Hello,
Hi,
Toby.
guys. Thank you so much, Jacob. Hi, guys. Good afternoon. My name is Toby Loba Adejimo, and I'm the program manager at Amoe. I'm very excited to have all of you here for today's webinar. I can see people already online on Zoom and on YouTube. Awesome. Quickly, let's move on to the task for today. Now, just a quick and just a quick and little housekeeping rules before we start. If you have any questions during the session today, you have any linguistic propositions, please wait till the end of the session to avoid lag or intermittent disruption during the presentation. You can leave your questions on Slido using the event code 63222. Again, you can leave your questions on Slido using the event code 63222. Without further ado, let's turn the table over to Shola as he has a few words to say before we begin today. Over to you, Shola.
Thank you, Toby. Good afternoon, everyone. Welcome yet again to our Saturday's webinars. It's exciting to have you join us again. We're always happy to connect with everyone from across Africa who is following this program and bring, of course, a new edge by inviting some industry experts to come share their best practices or from their wealth of experience so that our own careers and our own path definitely can be stronger. Today we have someone special who is going to be speaking with us as well, Ifeanyi Okuchi. Ifeanyi is an AI data scientist and a machine learning research assistant at the University of Waterloo, Canada. I don't want to blow his trumpet too loud. We'll keep it at that. Of course, you will uncover and learn a lot about him during the session when he's sharing with us. And there's a common saying that smart people learn from their own experience, but wise people learn from the experience of others. Today, we're going to be considering breaking into the data science space. As we forge our own path in this field, it is important that we are able to leverage the lessons learned by those who have gone ahead of us. And today, Ifeanyi is going to help us with that by sharing from his experience and, of course, that of people who have gotten started on this field, and of course recommendations and ideas on how to get started so that we can avoid pitfalls and be better prepared for ourselves as we create and forge our own path on this journey. Thank you once again, Ifeanyi, for joining us. We're excited to have you. I'll hand the mic over to you now.
Thank you very much for having me here and having the opportunity to share my experiences with everyone on this call today. So I'll just begin by sharing my screen and let me know when you can see it. Okay. Can everyone see my screen at this point?
Yes, you can see your screen now.
Okay, so I'm going to be talking about breaking into data science. And I'll introduce myself. My name is Ifeanyi Okuchi, and I'm an AI data scientist at Focus 21. I was a machine learning research assistant at the University of Waterloo, but I have finished with that. So now I'm just working full time as an AI data scientist. Towards the end of this presentation, I'll give more details about myself and how I got into this position where I am right now. So the whole buzz around data science, or the job title data scientist, actually started in October 2012 when Harvard Business Review made a very interesting article talking about data scientists being the sexiest job of the 21st century. And since then, the interest in data science has been increasing exponentially since then, and everyone wants a piece of the cake. The role was described as something very exciting, something very important, something that pays very well at the same time, and something that there was way more demand for than the supply. So it was a really growing field. So this article was one of the key reasons why the boom in the interest in data science grew really rapidly starting from 2012. So despite what the article says, that data science is a very interesting field, there is way more demand than supply. It's a very interesting take because when we look at the data science job industry and you're trying to get into the data science job industry, it seems that might not be the case. Why do I say that? There is indeed a very high demand for data scientists, but in quotes, there's a high demand for very experienced and skillful data scientists. And that's where the problem comes in. Because data science is considered as a largely senior level role. So they expect people who know a lot about a lot, and that's just putting it mildly. And for the average data science job application would require a minimum of a master's degree. So that shows what the expectations are. So while there is a high demand there for data scientists, as they say, but that phrase needs to be put properly. And the actual thing is a high demand for highly skilled and highly experienced data scientists. And the problem why it's difficult to break into data science is having or taking yourself from being a novice to someone who would be considered highly experienced or highly skillful in the field of data scientists, in the field of data science rather. Also, data science is a highly multidisciplinary field. You're expected to know a lot from different fields. So from this little diagram on the right here, you can see they expect you to have a fair understanding of mathematics, statistics, data visualization, machine learning, domain knowledge, coding, and this is just a few. And a lot of these areas, most of them have nothing to do with each other. And based on what current curriculums are like today, well, today it's getting better, but in the last few years, there were literally no data science curriculums. So if you go to school for engineering, you might just have a grasp of maybe some coding, some math, some stats, but nothing in depth in them. If you go to school for mathematics, you get an idea of math and stats. If you go to school for economics, you may have an idea of statistics and maybe data visualization or maybe some domain knowledge. So the traditional educational programs we have do not equip you to know each and every area that is required for data scientists, and that's why it's really difficult. So today there are some programs that are where there are some schools that are going to have data science undergrad programs. Well, there's a lot of grad programs in data science as well. So now they're trying to bridge that gap. But previously, the traditional educational programs we have did not suffice to provide you with all of these relevant skill sets. That's another reason why becoming a data scientist or breaking into data science is difficult. And third, there's there's a higher demand for experienced data scientists. That means there's only very few entry-level roles. And because of the boom and the excitement around the buzzword data scientist, too many people want to get into it. Too many people are trying to break into it. Too many people are trying to learn the basics. And then there's too many people who are flooding the entry-level data scientist space for the very few roles that are available. That's another reason why it's difficult to break into data science. And also, even in industry, it is confusing what a data scientist is. Different companies have different definitions of data scientist. You will find from one company to the next, the job description for a data scientist position is a totally different thing from the next one. So the fact that there's not even a strong consensus on what a data scientist is makes it even hard as well, for especially for newbies to break in, having trying to know where to focus on. That's also another difficulty. Another difficult thing that makes it hard to get into data science is a rapid change in technologies used by data scientists. What do I mean? Um, if you begin to learn data science, some of the first things you learn, maybe some Python packages. You use NumPy, Pandas, SciPy, and the likes. But in industry today, with the kind of huge data, most of these are not even used as much. We find people use tools like Hive, PySpark. You see big data tools that like Hadoop. These are way more advanced tools that are actually more valuable in industry because you're dealing with petabytes, not even terabytes of data, and you can't do that with pandas. So having to continuously be develop your skills to adjust to the new technologies that are available makes it even more difficult to be a very skilled data scientist, because the moment you learn a particular tech stack, you realize that that particular tool is becoming outdated. It's not even as valuable in the industry anymore. That's another problem. And then so many companies are not even structured enough to properly utilize data science. Either they're not collecting data, or their data processes are not being organized properly so that they can be utilized by data scientists to derive insights. This makes it difficult for them to even decide to hire data scientists. So, and I can say that for every data science posting you see out there, there's at least 10 more software developer postings, because in the software development space, be it from web to mobile, everybody knows what they want and everyone knows how to utilize it. And that's not the case for data science, because so many companies are not even structured to be able to utilize data science. That makes it even harder to get into data science. So, for having like applied for so many data science positions myself, and having also created job postings for my company when we're hiring, there's some skills that are required by data scientists. And if you have some of these skills on your resume, not just theoretically on your resume, if you have it on your resume and you actually know how to use them, some of these will take you really far. Again, there's way more, but these are some of the most common ones, and I kind of categorize them into different groups. And again, you'll see the problem I was referring to, where there is a diverse skill set that is required, and all of these may not necessarily be derived from one source of education. So it requires a whole lot of learning. For programming, some of the most popular ones that are used by data scientists are Python, R, MATLAB, and SAS. And for me, I would personally recommend Python, because it's among these other among these four languages here, it's the only one that can be used for full-end software development, and it can also be used for analysis and visualization. Code written in R can barely be embedded into software, unlike that with Python. So I usually recommend Python for people. And then when you come to data analysis, SQL, Pandas, and Spark. I know lots of people just jump straight right into using Pandas, but trust me when I tell you, you need a very strong understanding of SQL if you want to break into the data science space. Data science is more than getting a CSV file, opening it with Pandas, and creating a scikit-learn model and writing .fit and you think you're done. Hell no, it doesn't work that way. in the real world, the data you would work with is messy, it is all over the place, and only SQL can save you. So you really, really need to get a very strong and hands-on experience in SQL. And another reason why getting experience in SQL is because at times, because of the difficulty of getting into data science, you might might be easier to get a role as data analyst. And for a data analyst, you would also require SQL a lot. So having SQL on hand gives you lots of options as well. And then for data visualization, uh, there there are different tools for data visualization, and if you can master one or two of them, I think you should be in good shape. And within Python, you have Matplot library and Seaborn. Within R, you have ggplot, and then there's dedicated tools for visualization such as Tableau and Power BI. And then you also have to have a strong statistical background from descriptive statistics, inferential statistics, A/B testing, time series forecasting, and you need to know how to do this using some tools in Python, specifically using SciPy and stats models. And then you need to have an understanding of machine learning. And again, machine learning goes beyond taking your data, splitting it into three or two portions, fitting your model, and then predicting. You need to understand the theory behind the machine learning. You need to understand which model to use for a particular problem and why that is the best model. You need to understand validation. You need to understand data leakages. These are theoretical things you would need to understand to actually do a good job as a data scientist. It goes beyond this superficial level of just writing 3 lines of code and then making predictions and getting high accuracy. Even determining what metrics to use. In so many problems, accuracy is not even the right metric to use. So all of this are things you would need to know as a data scientist. And then for more advanced libraries such as Keras, TensorFlow, and then XGBoost, these are things you need to have hands-on experience with if you were to succeed as a data scientist. And then if you're going past the level of just predictive analytics or forecasting or A/B testing, you need to go into the realm of neural networks. And here we're beginning to move into deep learning. And from what I've realized, previously, people who do work in natural language processing, computer vision, reinforcement learning, and other specialized fields used to be classified data scientists. But now, more and more, they are being separated. A lot of them get referred to as research engineers. A lot of them are called machine learning engineers. A lot of them are called natural language processing engineers or computer vision engineers. So these ones are being split away from the title of data scientist little by little. But these are areas that require high specialization and they're for particular domains. And within each of these areas, there's a whole lot to learn. There's a whole lot to learn within each of these areas. So all these are like different areas on its own. You find people who do natural language processing, and within natural language processing, they are specialized in machine translation, and that is a whole field on its own. So data science as a field is so broad, and if you're in the learning phase, it can really be overwhelming deciding what path to go through and what to learn and what not to learn. And also, you also need to learn about cloud computing. Again, because we're working with petabytes and terabytes of data, all of this data cannot be processed on hardware that is located either in your local machine or in your office. All these are run on the cloud, and the major cloud providers are Amazon Web Services, Google Cloud Platform, and Microsoft Azure. So you also need to have hands-on experience on how to use these platforms for cloud computing and parallel processing. And also, as a data scientist, you're also expected to have a fair idea of software development and software development processes, such as version control and deployment. When you build a machine learning model that predicts A from a set of B, if you want to use it, this model has to be deployed somewhere, either on a website where the user comes in and they fill in A in a form, and then it gives them output B. So that is deployment. And as a data scientist, you have to have a fair idea of deployment. So that explains that you have to know the end-to-end process from the beginning to the start. And then also domain knowledge, because data science is applied in so many fields, from healthcare, retail, technology, finance, banking, etc. You would need to show some domain knowledge in order for you to be preferred as a candidate over someone else. If a medical company is hiring for a data scientist, someone who has experience in the medical field, and then knows the data science process and tools, would most likely be picked ahead of someone else who knows the tools as well, but doesn't have experience working in the healthcare space. So that's another reason why it's difficult to get into data science, because a lot of these companies have their own unique problems in their own unique fields, and they would rather pick people who have similar experiences. This is another difficulty. So, and this is something that you have to watch out for as well. And then communicating business problems. So this is a very important skill that data scientists require. You have to be able to get the data, make sense out of it, and then communicate it in a simple way for upper management to make sense out of. You also have to be able to transform the data into good insights and then communicate these insights and then be able to tell stories with the data. This doesn't seem like a difficult skill, but trust me, this is a very difficult skill that you would need to learn in order to be a successful data scientist. So when people ask me how do they get into how do they learn data science, the short answer is figure out right now where you are. What do you know? If you figure out what you know right now and you're able to figure out what part of data science would interest you the most, then you can create a path for yourself, which might be unique to you. But otherwise, the generic path I usually recommend for people is, one, to get comfortable with programming in Python, and then two, to begin to learn how to manipulate data using pandas and SQL, either within Python or you're using a SQL Server. Four, I also advise people to begin to learn data visualization. After you get your data, you begin to manipulate data. You can analyze the data. Then you also show your results, and then that's where visualization comes in, using the Matplotlib libraries, Seaborn and Tableau. And then you begin to learn how to build machine learning models using scikit-learn, and then after that you can start going more and more in depth into machine learning. And then you begin to practice. I'm going to emphasize on this later on. Why practice? You see, everything from step 1 to step 6. Trust me when I say millions of people have done it. The question is, how do you stand apart? How do you set yourself out of the crowd? Everyone has taken one course in Python or done pandas or Matplotlib or sklearn or even up to deep learning. So what? That's the question. How do you make yourself unique in a world where there is so many people who want entry-level data science jobs, and there's also so little entry-level data science jobs? So here I talk about how to stand out from the crowd. So one of the things I recommend, and things that also worked for people that I know, is work on multiple projects. Now, this project must be very difficult. One, this project has to be relevant to a form of business or add some value to the world. Two, this project must be rare, not something you find on everyone's CV. Just like you're applying, and then someone asks you what projects have you worked on. You say you worked on image classification on MNIST dataset. No one's going to take you seriously. You need to work on a project that is rare, and that an interviewer will see that on your resume and they'll be like, "Wow, this is something interesting." And then you have to do projects that are, again, very relevant to some form of business. And then my advice is to have a project that is difficult, relevant, unique in multiple domains. Because it is difficult to break into entry-level data science, it is also very difficult to be picky regarding what aspect of data science you want to go to. You can't be picky and say, oh, you just want a role where you do more forecasting, or you want a role where you do more of A/B testing, or you want a role where you just be doing more of computer vision. As an entry-level person, you don't have that privilege to be picky. So that means you have to try multiple options, focus on multiple areas, and then see what works, because it is difficult to break into. And the reason why that is very important is, the only way you can show this is by having difficult relevant projects in each of the major areas of data science. If you have one natural language processing project that is really difficult and really relevant, and you can describe how you went about it from end to end. You have one in computer vision, you have one in recommender systems, you have one in anomaly detection, you have one where you're doing traditional, let's say, business case forecasting. If you have like 6 projects in all of these different fields that are really difficult and really complex and also very rare, depending on the job you're applying to, you can know which particular ones to put on your resume at that point in time. That way, you have multiple options. You have, and doing these projects, you would have learned a lot. Most of the things I learned while coming in were not from like the courses I took. They were not from the assignment from the course I took. It's from the extra projects I worked on my own. Those projects taught me way more than anything else. So aside getting the knowledge, you're setting yourself up for having multiple options. Also, if you want to break into the field, you have to like have a really professional LinkedIn profile and the CV. Statements like data science enthusiast, aspiring data scientist, none of that should be anywhere close to your profile. When people see this, the first thing that pops up is, okay, this person's a novice. They probably don't know what they're doing. You're doing yourself more harm than good and saying that. If you know you're not a data scientist, you don't even put anything there. When you know you've taken so many courses, you've done so many projects, you've done, you know a lot about a lot, then you can say something about being open to data science roles. But saying things like data scientist or data science enthusiast or aspiring data scientist, this do not look good on you on any way. So you have to brand yourself as a professional on all profiles: LinkedIn, GitHub, Twitter. So when I say create relevant projects, when you create these projects, you have to put them somewhere where your potential employers can see them. And most popular places is GitHub. You host your code. You have a personal repository that is hosted on GitHub, where someone can come see your computer vision project, look through your code from end to end, a well documented, well written code that explains your whole process from beginning to end, and then they can begin to see your skills through that even before interviewing you. So that is very, very, very important. Also, another way to break into data science that I've seen work to a lot of people is constantly writing articles on data science and machine learning, either on LinkedIn or Medium. Now, about different concepts and trying to teach different concepts. Here's why. 2 reasons why this is really good. One is before you write an article teaching something, that forces you to actually learn it and learn it properly, because you don't want to embarrass yourself. That's one. Secondly, that shows that you are someone that can add value to people, and companies look for people who can add value. And 3, it also takes you from the level where you're being seen as someone who may not know what they're doing to someone who knows enough to actually teach people. So it does a lot for you if you're constantly pushing articles, either on your Medium blogs or on your LinkedIn articles that continue to show well documented and well articulated articles on different data science and ML concepts. This will really help you a lot. And if your interviewers can look up your name and find these articles, it will be really impressive for you. And then data science requirements vary a lot from company to company. And whenever you're applying to any company, you need to show that your experience uniquely aligns with that company. Again, that's where things like domain knowledge comes in and stuff. So if you're applying to a company, let's say a medical company, and they're requiring a data scientist, it will do you good to have projects on your resume where you've worked on, say, using computer vision to locate breast cancer in X-ray images. If you have that on your resume, that kind of gives them the feel that you have experience working in the health domain, even though you've not worked there officially. But having projects in that domain helps you at least show that you have some experience in that healthcare space, and then you'll probably be a more suitable candidate for them than someone else who knows the concept but hasn't really applied it to that particular domain. So this is something you can do to help yourself stand out and not look like you don't have any domain knowledge. And again, because I said it's difficult to get into data science because the tools continuously change, you have to keep learning and learning and learning and learning. There are so many tools out there, and newer ones are better than the old ones. And because you think you're a master of the old one, and you want to die on it, then your whole career is going to die as well. You have to constantly update yourself and keep learning new tools, and then be patient because it's a really long process to get into the science. You have to be patient. You have to check your entitlement and just keep learning and learning. So if you look at this chart I have on the right here, so on the x-axis you have your skill level, and on the at the top, on the right axis, on the y-axis you have the value you have to offer, or the value that the potential employers see from you. As you can see, the more skills you have when you start, your value increases very, very little. We have to keep learning and learning and learning, almost towards the end, to the high end of the skill set, before they start seeing more value in you. The reason is, at the initial stages of your skill set, when you're coming here, nobody, or rather, so many people have all these skills here. All these skills at the beginning point. So many people have them. So many people have them. So nobody's going to see value in you for having them. But when you keep learning and learning and learning, you get to this point where you can begin to break forward. Where get to the point where most people stop and you keep going and learning. That's where your value begins to show. And when your value begins to show, that's when companies will begin to see you as an asset. So you have to take your skills to that level way more than most of the population before you can actually be seen as someone valuable, and then some company want to hire you on their team as a data scientist. So that brings me to talk about my story and how I got into data science. So I finished my bachelor's in industrial and production engineering at the University of Ibadan in 2016, and my that program had a lot of things that in it that current data scientists use. We did concepts such as forecasting. We did things such as operational research and optimization, and all of these are part of the everyday data scientist job. But then we never knew what data science was. So it was after I finished, and then during my NYSC, then I started seeing more articles about analytics and data science and why that is changing a lot in the business world, and why that is making lots of things change, and how it's a very, very lucrative field. It sounded interesting to me, but I still didn't know as much. But then I wanted to pursue grad school, so I applied to the University of Waterloo, and I got a fully funded offer from them, and to do a research based master's program. And during my research, my supervisor, put me on a project. So here, the way research works is the different organizations, be it companies or government, they have their requirements, and some of these things are things they are not sure how to go about them, and because they're not sure about how to go about them, they can't just employ people to go about them, because most of the time these are problems that have not yet been solved. So these problems have been given to professors in universities, and then they provide these professors with some amount of funding to research into these problems and come up with ways to solve them. These professors then hire students under them and then supervise them, and then the students work on solving these problems. So my research was funded by a very huge corporation, and they buy and sell groceries to customers all over Canada. And by groceries, you mean everything from, so you just have this huge supermarkets where they sell like foodstuff, clothes, health, some drugs, body spray, like literally everything you find in a typical supermarket. So they have chains and chains of these stores, and for their fresh food section, like tomatoes, onions, they buy this from farmers, and when they buy from farmers, they sell to customers. But the problem is the farmers don't have specific prices, and those prices change on a day-to-day basis. So the problem became, how do they know on what day the farmers will give them a very low price, so that they will wait and then plan their purchases for that day, instead of buying on any random day and then getting a high price. So to do that, we had to build machine learning models to predict how much the farmers are going to sell their produce for different days into the future. And to do that, we had to consider so many things that affect the farmers' prices, from how much they produce to the weather to satellite images of their farmlands. We use all of that data to predict how much the farmers would produce and then how much they will price their items. So knowing how much to price their items, the company can then plan on what date to buy so that they will save costs and then save them money. And that project is planned to save the company billions of dollars in the long run, because they are saving money and then but they're buying on the least possible at the least possible price within the time horizon. So it was while I was working on this project, that's where I had to learn a lot about machine learning. And I took lots of courses in school officially, about I think about three or four courses in school on machine learning and data science. And then I did a lot of data science related courses on Coursera. If you've gone through my LinkedIn profile, you see a lot of them there, and that's not even all of them. I've at least 20 plus courses on Coursera from different aspects of data science and machine learning. I've covered literally every area. And then doing this, I also worked on multiple side projects like I talked about, projects in anomaly detection, projects in breast cancer detection, projects where I had to predict whether or not a pregnant lady is going to have a complication during pregnancy or not, based on ECG signal scans. So like I work on multiple projects like that in different domains, and those projects taught me a lot. The courses I took taught me a lot about the theory, because I didn't just take courses that just taught the applied parts. I took courses that taught the theoretical part and the math and algebra behind all of these algorithms. And then I would work on multiple side projects to see how this worked. And while doing all of these courses on the side, as well as my master's program, I also started applying for jobs, and then I started working as a part-time AI data scientist as well. So the knowledge I acquired from multiple fields while working as a part-time data scientist, while working on my huge research problem in school, while doing multiple side projects all at the same time, kind of gave me a very holistic view of data science and all the possible areas. So if you look at this chart I have on the right, it shows, like, again, the skill sets required by data scientists. On the top here, you see statistics, machine learning, and optimization. And I can pretty say much. I learned statistics and optimization from my undergrad. I had the basic idea from it, and then machine learning was all over the place, either from Coursera, from school. That's where I learned about that. And then programming, and I would say programming mostly came from lots of the courses I took online and through practice. So I became good in programming. And then also for visualization, my skills in visualization came from lots of the courses I took online. Then business and domain knowledge. Business and domain knowledge I got came from both my master's program, where I was working with a huge company in the retail space, and then my side projects where I was doing lots of work in the healthcare space. Just the interesting thing was, so for my job at Focus 21, where I currently work, what I do is we work with a medical company that treats kidney stones, and the kidney stones are, the way it's typically treated, you have X-ray scans, and then X-ray scans the kidney. The technician looks at the kidney, and then there's this device, just more like a remote control. You point it towards the kidney, and then it releases waves, and then the waves break the stones into small pieces, and then it comes out as urine when it's fully broken down. But to do this, you have to set the power level on the control, set how many shocks to use, and stuff like that. If you use the power level that is too high, it will hurt the patient. If you use that is too low, the treatment will take too long, and that will also cause some complications. So my work there is to create AI models that will take in the X-ray images, locate the stones if they're there, tell the technician what the properties of the stones are, and then recommend what power level and how many shocks to use for this particular stone that will break the stone successfully without leading to further complications. So that's my job there. And during the recruitment process, one of the reasons why I actually got this offer was because I had a project where I had worked on using machine learning to scan X-ray images looking for breast cancer. That was one of my side projects. So having that on my resume really helped me show that I had experience in that field. It literally looked like I had the domain knowledge. That's why I can't overemphasize the importance of having really difficult and really relevant projects. So all of these actually helped me transition into this field right now, and it's been a very interesting process. And one thing I can tell you for sure is the moment you start, it looks like you're excited because you're learning a lot and you're learning a lot. And then you get to a point where it seems like the more you learn, you realize that you realize the more you do not know, and then it begins to get frustrating at that point. And then that's where most people stop. But if you keep pushing at that point where it's frustrating and it looks like you're learning more, but you already need this more you don't know, if you keep on pushing and pushing and pushing and you break through that phase, that's when you can get to the point where you will be highly skilled. And by highly skilled, I mean point where you break through this line and you become very valuable. So again, it gets really frustrating at some point when you're learning and learning so many things, and then you're realizing that the more you learn, the more you do not know. But if you can keep persevering and keep grinding and keep learning and keep updating your skills, you get to a point where you can break through that barrier of frustration and keep progressing. You get to a point where you become very valuable, and then at that point, you begin to reap the reward of all your work. So that's basically what I have to present today regarding transitioning into data science. And I think, again, because data science is a very unique field and everyone comes from a different background, the process can be slightly different for everyone. But at the end of the day, it's still some core skills, some similar skills you have to get. The major difference, if you look at it, is people are coming from different backgrounds, but data science requires different skill sets. So your background tells you what skill sets you already have, and then what other skill sets you should look for. If you're coming from an engineering background, you know you have some math and stats background already. Then you should be looking for how to understand machine learning, how to program knowledge. If you're coming from a business or economics point of view, you can say you have experience working with businesses and how to translate business problems, but then you have to develop the programming, the math, the stats knowledge. So everyone's coming from different background, but that shouldn't be a problem. It just tells you you know where you are and you know what else you need in order to make yourself competitive. So at this point, I'm open for more questions. Thank you.
Amazing if I breaking into the data science field.
Yes. Okay.
Okay, from your end. Your brilliant presentation tugged at my heartstrings. I'm hearing an echo. Okay, let me move quickly. Okay. Your brilliant presentation tugged at my heartstrings, especially your story. Now I see reasons with Isaac Newton when he said, "If I have seen further, it is by standing on the shoulders of giants." Even at that, the engagement from our interns on Zoom and YouTube has been shattering glass ceilings. So moving on very quickly, we have some questions for you. The first on my list is from someone, from an anonymous on Slido. Now the question is, how do I get remote data science remote jobs after graduation with only an internship experience?
Okay. Getting a remote job, honestly, is not any different from getting a regular job. It's you basically require the same process, and depending on your location, remote jobs might be more common or not. If you're living in Nigeria, for example, you're less likely to find remote jobs than living in the US or in Canada. So it also depends on your location. But the requirement for getting a remote job is not any different from getting a job where you have to work from the office. It's the same set of requirements, and you have to go through the same process to make yourself appear really valuable. And what I would say, getting a remote job might also be more tricky because someone is going to hire you, and you're going to be fully remote. It kind of requires a little bit more trust in your abilities because there's literally no one seeing you in person, seeing your work. So that might put an additional difficulty. So, but that's what it is right now.
Right, thank you, Ifeanyi. Now, this intern wants to know if Hadoop or Spark is a necessary knowledge for an entry-level position in data science.
Okay, so Hadoop or Spark? I would say PySpark is more relevant. But before learning PySpark, I advise you learn SQL properly first, because within PySpark, a lot of what you're going to be doing is using Spark SQL, which is calling SQL within Spark. So my advice is to learn SQL properly and then look into PySpark.
Okay, thank you, Ifeanyi. Now, this is a technical question also. Data science is a math-intensive field. Is it better to focus on the maths first before delving into the implementation technologies, or vice versa?
Honestly, looking at the math first is advisable, but it's a little bit more frustrating that way. But then going to the application first might make you feel all excited, like, oh, it's really easy, it's this is that, but you won't pass any interview process, because in the interview process you will literally be asked about the theoretical stuff, and then you have to show it practically during coding challenges. So my advice is to do both hand in hand. Take courses that would give you a touch of both the theoretical and the applied parts. You need both equally.
Okay, Shashank here wants to know what you look for when interviewing a candidate.
Again, the specific requirements are role and company dependent. Really role and company dependent. But yeah, there are some basics like everyone would look for. There are some basics everyone would look for. Things like your theoretical understanding of basic machine learning, your theoretical understanding of statistical concepts, inferential statistics, A/B testing, probability theory, Bayes theorem. These are basic things that people would ask for. And if you don't know any of these, and you don't know the basics, and that's going to be difficult for you to break through. Also, after learning the whole process, you think you've learned enough, you build a lot of projects. I advise you to like take time to go through data science interview questions, and then what the different categories. You see the one in statistics, see the one in machine learning. When you look through them, you have an idea of what will be asked in data science interviews. And the good thing is, most of the things that are asked in data science interviews, you'll find them online in some of these websites that explain data science interview questions and their possible answers. So that's a good resource. But again, you have to know the basics at the very least. And then the other things will be dependent on the company and the role.
All right, thank you very much. Basics first at the very least. Now, Alaji Dots on Zoom says, you mentioned getting involved in different projects that are not over the place, and getting unique projects. Now, here's an interesting one. How do we get these unique projects?
So what I said was, you have to work on projects that are unique, that are difficult, and in different domains. So there are a lot of places where you can find some of these problems. If you go through cargo, for example, there are some cargo challenges or some projects on some data sets on cargo that are really difficult to work with. And if you can work with them and then build something around it, then that will be really impressive. Also, specifically searching. Say, for example, you want to work on a project in anomaly detection. You can start Google searching difficult projects in anomaly detection. You can see really difficult projects and find the data sets openly available. Then you can begin to work with it as well. So if you need a unique project in a particular field, you can try Google searching to see what data sets are available. Because again, with data science, if you don't have the data, there's nothing you can do. Right? So some of the best place to find those data sets would either be in Cargo or UCI.
Okay. Also, about SQL, there are different aspects of it. ETL can be done with SQL. What aspects of SQL are we to focus on?
Okay, so when you're searching for SQL, typically I advise you to search for SQL for data science. You will see the aspect of SQL that you usually require for data scientists. So whenever you're searching up SQL, either as a course to learn or something, just you put in SQL for data science. That will give you a more specific aspect of SQL to focus on.
Okay. And now here is one about prerequisite skills. So how can one actually blend learning all these prerequisite skills with carrying out multiple projects and also working a job?
Pardon, can you please repeat that question?
Okay, how can one actually blend learning all these prerequisite skills while carrying out multiple projects and also working on a job?
Okay, so here's the thing. All of these do not have to be mutually exclusive. You can learn a skill, but when you're working on a project, it's the only time you actually have to try out the skills and actually hone the skills. So these two things do not have to be mutually exclusive. It can be all one and the same thing. You can be learning you can just learn a concept online and then you're trying to implement it for yourself by working on the project. It's still part of the learning phase. So even though you're working on a project, you're also still learning that in that process. And regarding work, it depends on the work you're doing. If you're doing work where you're also using data science, then you can also be learning on the job as well. So again, all that can be combined into one to be one huge learning experience.
Okay, yes, from Olawale. Please, what opportunities are available for a master's program in data science, and how did you determine the research project you worked on in the university?
So determining my research project, again, here if you get accepted by a prof, the professor usually has a domain area of kind of things they work on, and then when they accept you, you know you're going to work within that area as well. And it also depends on the project that the prof has available at that point. Then probably one will be assigned to you, or you'll be asked which one you want to work on, depending on your skill set and your interest.
Okay. In carrying out multiple projects, especially those very difficult and rare ones, how do we get access to this data because of the challenge of accessing data?
Again, if you want to get openly available data, UCI and Kaggle are very good sources. And then there's a new one, Google Dataset. It's a repository by Google where several datasets are stored as well. So you can explore those three options: Kaggle, UCI, and Google Datasets.
Okay, thank you so much. Ifeanyi, here's the last question for this session. Is master's compulsory for data science role, or do bachelor holders also have the same opportunity as master's holder?
Okay, so I've not really checked what the data science market is like in Nigeria. But here, I realized that over 90% of data science positions require master's degrees at the minimum. Over 90%. So you can break in with having a bachelor's here, but you have to show like you've had multiple internships. So in my school, for example, the undergrads here, they have what they call co-op. So from semester to semester, they go school internship, school internship, school internship. So you find an undergrad who, by the end of his program, they've had experiences with doing data science as a data scientist at Google, at Facebook, at Microsoft, at LinkedIn. When you have all that experiences as internships in such companies as data scientists, even if you're applying to a job where you're required to have a master's degree, obviously you'll be clearly considered because you have a lot of relevant experience. So it might be easy to break in if you have relevant internships in that field. But for most of the jobs, at least here in North America, master's degrees are usually required. But if you have the skills and you show the experience, I don't think that should be a problem.
Okay, another question just came in. It looks like we have a few minutes left. So, can you explain what you mean by the theoretical part of machine learning?
By theoretical part of machine learning, I mean the math behind machine learning. So you want to do support vector machine. How does a support vector machine work? You have to understand it's an algorithm that creates a dividing hyperplane between two different spaces. How is the hyperplane created? What mathematical optimization function is used to optimize that hyperplane that is you're using to differentiate between class A and class B? All that is the math behind the machine learning. When you go to your scaling and you say so model dot fit, it's a huge ass code that is written behind the scenes by SLN or the developers that runs all that math behind the scenes. So you have to understand what math is going on there. Understanding the math behind it literally helps you understand if this algorithm might even be best for this particular problem. So again, if you want to do neural networks, for example, you have to understand how neural networks work. You have to know what is forward prop, what is backup propagation, what is dropout, what is batch normalization. How do these things work mathematically? These are things you need to understand. So yeah, you have to know what convolutions is. You don't know what strides and kernels are, how they work, how they compute, how they go about to carry out dimensionality reduction. You have to know all of these in a theoretical mathematical aspect. And if you don't, then you want to know if you should be using that particular model at that point in time, and you might not even be able to go through interviews because those are things they ask for.
Awesome. Thank you so much, Ifeanyi. It looks like we've covered a lot of questions. Is there anything else you'd like to say before a final wrap up?
Yeah. In conclusion, I would say, and I'll be honest with everyone, it is a very, very difficult process. I'm not going to sugarcoat it for you. I'm not going to say, oh, data science is this. You just do this, take this course and take that course, and then you can just data science is. It is not going to happen. You have to want it. You have to learn and learn and learn and learn and get frustrated with learning and then continue learning. That is literally the only way to actually to set yourself apart. And when you can do that, when you can overcome that frustration and find yourself at that point where you can break and become, when your skills begin to count as valuable and you begin to stand out from the crowd, that's when you begin to reap the benefits. So you just have to be patient and continue learning. And people are asking about what courses to take. There are a lot of courses on Coursera, and if you check my LinkedIn profile, literally most of the courses I took, I would recommend them for anyone. If you look through my LinkedIn profile, you see some courses that I took on Coursera, and then you can always take them for free and apply for financial aid. Those courses are very relevant and they will really help you a lot in your learning journey. So I wish everyone good luck, and I wish you the strength to continue to learn because it is a very difficult thing to do. So I wish everyone all the best, and thank you very much for having me.
Amazing. Thanks again, Ifeanyi. Thank you, everyone. We appreciate you for being here today. Thanks again for joining us, and we'll see you next time.
Thank you very much.